So first, I want to briefly remind you the reasons why we are here today and the purpose of this workshop and why we are organizing this workshop here and now. And for that, I will give you a brief overview about the local context, what I call the local context. So the University Paris-Saclay, the Institut Pascal, and the Saclay Plant Science Network. And after a few words about the global context, I will give you a few snapshots of the current challenge we identify, or the people identify in plant science. For those who were here last week, you already saw several seminars about this current challenge, and you will see a new seminar during this week about this challenge. You will have different overview of this point. And after I will finish with the objectives of the workshop. But first of all, I wish to acknowledge many people. And first of all, Olivier Martin, who is there, because he's the co-chair of the workshop, a member of the University Paris-Saclay, of course, and also of the Institut Pascal and the SPS network. And he really initiated this workshop. It's really due to his initiative. I want also to acknowledge people from the Institut Pascal, the director, Yves Balonsky, and the deputy director that made the introduction last week, Jacques Bitoun, also because Jacques was at the very beginning of the University Paris-Saclay as a former president of University of Orsay and taking care about the organization of building of the life science division. Aurélie Landau, that is general secretary, and Francesca Sconfianza, already presented by Marie-Jeanne, because she's the manager of our project, of the project folder. I wish also, of course, to acknowledge SPS organizers, so Olivier Martin and the executive committee, member of the executive committee of the SPS, the two managers, Marie-Jeanne Cellier, you just saw, and Francesca. I give you the picture of these three people because if you need any things, you can go to them to ask any question. And I wish to acknowledge also the chairs and coordinators of the different sessions. You already saw many of them, at least the two first sessions, and also people from transversal discussion. And last, of course, I wish to acknowledge 40 speakers and all the participants to the workshop. So first, to start about the global context, the University Paris-Saclay. Okay, many of you know, but it's important to remind that it's benefiting from a national investment decided in 2010 that together to group many different actors of the southwest of the Paris suburbs to develop a new University Paris, a new type of university close to Paris, and what they call green and city campus. They wanted to develop a city campus because people who were in Orsay previously knew that it was not really a city campus, so it was one of the purpose. And this is a view of the current campus. The campus is about 6 kilometers away from CIE and Saint-Croton-Soleil to the east of the campus. This is mainly the University Paris-Saclay, but you have also on the east of the campus the Institut Polytechnique of Paris, that has his own campus. As shown by Marie-Jeanne, the Institut Pascal is here, just on the border of the forest, and you have the two main hotels of the Congress. What to say? And all this investment has been made in the frame of the Paris-Saclay University. This is a new experimental university officially created in 2020. And the purpose was to build a research university. It has been created by the association of 14 founding members. Of course, the former University of Orsay, with two associated universities of Saint-Quentin and Évry, with 4 engineering schools, that is to say AgroParisTech. It is very important for us in our area. Centrale Supélec, École Normale Supérieure, Paris-Saclay, and Institut d'Optique, and the 7 national research institutions, CEA, CNRS, Institute for Mathematics, INRAE, of course, INRIA, INSERM, and ONERA. There are about 48,000 students, 17 faculty and technician administrative that are taking care of about 220 laboratories, and more or less it represents 15% of the French research if we take into account the whole Paris-Saclay area. So the main objective of this university was to meet or tackle the knowledge and societal challenges. You can see here a definition of the 7 main challenges defined by the University Paris-Saclay. And you can see on the top that at least the 3 first are really related directly or indirectly to plant science we are talking about this morning: health and well-being, energy, climate, environment, sustainable development, biodiversity, agriculture, and food. So this is an important topic for the university, and it's shown like that and presented like that. And to meet this knowledge and societal challenge, they wish to develop the interaction between education, research, and innovation. And this is important in the 3 main area we are working on: life science and health, science and engineering, but also we have some social science and humanity. And the university wished to put science at the very heart of the society by different initiatives. We are acting as the interface between science and society. We develop some specific projects and initiatives, promoting academic freedom and encouraging public debate. We'll discuss a little bit about that this afternoon also, and working toward open science for the benefit of the society. And in this frame, very recently, UPSE as University Paris-Saclay, as many other French universities, support the initiative Stand Up for Science, of course, started in the United States, as you said. And in more general way, the university supports a fair and inclusive society by contributing to sustainable development, of course, we are interested in, and promoting a culture of equality and inclusion in general. So here today, we are at the University Paris-Saclay in the Pascal Institute, and this is one of the projects of the University Paris-Saclay. So it's exemplify what the university can do when all the actors work together. And the purpose of this institute is to provide a meeting place for a significant period of time, usually because the institute was built mainly at the beginning for physicists and mathematicians. They used to meet together for 2-3 weeks a month. It's less usual for people from biology, but this is what they have in mind for most of time, to facilitate the exchange of ideas, the formation of international collaboration, and across all the scientific themes covered by the University Paris-Saclay. As you saw, for some of you already, upstream, there is a place, usually in average, for 60 people to discuss in this theater or in the office. There are 26 offices above, as you saw, and some place to work. And there are state-of-the-art equipment in all the place, and the possibility to use Zoom in all the different rooms, and with a remote hybrid mode for discussion, etc. And the institute is developing several projects. And for instance, for this year, there were 14 programs that will be developed here. 5 programs are funded by the Institut Pascal. This is a case of our SPS Congress. And we are the first one. You will see that all the other congress are about physics, astrophysics, mathematics, etc. So we were quite lucky to have something on biology. And now the last part of the local context is plant science in Paris-Saclay. So there are about 100 people working in university, engineering school, or for the national research bodies on plant science. About 200 researchers and teachers and other technician, engineer, and of course, many students. We are lucky enough to have a dedicated teaching training facility for plant science. There are also some specific formation, master specialization, engineer degrees, and even a dedicated doctoral school for about 260 students. The campus, when we talk in terms of bibliographic indicators, is among the top campus in the world. The last time we tried to classify it, it was the 5th or 6th campus in the world in terms of bibliographic indicators, but it represents about 14 to 15% of the French publication in plant science. And also, we are lucky to have the Saclay Plant Science Network. This is a project funded as Laboratory of Excellence since 2011, and more recently as a graduate school of research since 2018. That gathered 6 institutes of Paris-Saclay, so some team of these 6 institutes, and we have a specific funding of the state for about 1.5 million a year. It seems to be, it could be low if you compare to the overall cost of these 800 people, but it's still 10% of the running cost. And it has a strong leverage effect that is very interesting. And it allows us to do some specific initiative at this Congress that we would have some problem without this funding. So the SPS objective and strategy are to support all the sustainable use of plants by knowledge acquisition, use, and dissemination. It was the purpose defined 15 years ago now when we built the project. And the purpose as the university was to do that by coordinating better the research, education, and innovation activity. And in the frame of the project, we also developed several outreach and communication activities. We identified 3 scientific challenges at this time. Of course, to understand the mechanisms that control plant structure and function, or basic work in most of the lab, but also as a new challenge, we wanted to develop a more predictive and more quantitative biology. We thought it was insufficient at this time in our environment, and also biotechnology for research, but also for innovation. And like that, we defined 4 thematic priorities that were the sustainable intensification of plant productivity in a fluctuating environment, the improvement of plant quality, food, feed, and for health and environment and industry, plan to understand the fundamental biological mechanism, and developing new resources and biotechnology for research and innovation. More recently, for the Graduate School of Research, we had 2 more initiatives about bioinformatics and specialized metabolites. But of course, all these objectives and challenges have been defined in 2010, as I said, or complemented in 2018. And of course, today, in 2025, we could ask if they are still relevant to answer, to tackle the challenge we have seen, and you will see more this week. Rapidly, briefly, the area of scientific activity for research, teaching, and innovation concern all genetic, molecular, and cellular mechanisms that control plant development, reproduction, and the interaction with other organisms in fluctuating biotic or abiotic environment. We are using all the approach and concept from biochemistry, biophysics, imaging, molecular biology, genetics, all classical approach, as I said, at the different scales. And we cover almost all the different fields of plant science at the moment, going from genome dynamics, expression molecular biology, developmental biology, reproduction, cell biology, primary and specialized metabolism, biochemistry, enzymology, evolution, biodiversity, interaction with the environment, biotic and abiotic, quantitative genetic, next breeding technology, new biotechnology, and molecular and cellular biotechnology. And of course, we could ask today if we have to define new priority, if we have to insist or to develop more some of these specific research. Along the research activity, we develop other activities for research, teaching, and innovation. And for instance, we have been involved in or organized several international conferences. One key event was the organization of the first Arabidopsis meeting in France in 2015. It's still the only Arabidopsis meeting organized in France. We organized also several summer schools, some meeting with a private company to develop and to interact for innovation, and also some very specific outreach events. Again, we could ask today what should be the priority in this investment in these different activities. So I finished with the local context, and now I will talk more about plant science, but most of the seminars you've seen already and that you will see this week are describing what I will summarize now and are the points of discussion. So we wish to, perhaps I forget, it was the objective, I forget the last point. Now I will describe the global context. I will give you some snapshot about these current challenges. As I suppose most of you are convinced, we think that plants are a major global challenge today for several reasons I will briefly describe now. Of course, the first one, as you know, we could not live without plants. Plants can fix CO2 gas into sugar and producing O2 through photosynthesis. And you had some seminar about photosynthesis, of the use of photosynthesis for many things, because of course, by providing this sugar and some carbon sources, plants are the start of the food chain. In the same time, they produce what we call renewable carbon chain. And as you saw last week, I had one slide. Plant could be also a mean for carbon storage in the soil. It will be discussed and also this week. As you know, that plants are quantitatively the most important living kingdom, and it's also related to what I just said. Plant could be a good way to store carbon, because 80% of the Earth biomass are constituted by plants. Plant can also produce many molecules for nutrition, for health, for agriculture, and for the industry and the environment, as you know. And also what is, I think, is important and will be discussed also this week, we have to keep in mind that during the last 60 years, the increase in plant production, this is a blue curve you see here, by threefold at least, allowed to absorb the demographic increase. This is the light blue line here. So we can say that agriculture has provided food security during the last 60 years. At least this is a fact difficult to understand. In the same time, we think that agriculture was crucial to economic development. Most of you know that agriculture is account only, I would say today, for 4% of the world gross domestic product. But for many countries, it's still very important. For some countries, and for instance, in Africa, it's still more than 15% of the gross domestic product. And also on this line, growth in agriculture has been shown to be 2 to 4 times more effective in raising income for the poorest compared to the other sector. So it's very effective to employ people and to feed people. So agriculture, it has been in fact summarized by many people, FAO, etc., can help to reduce poverty for 80% of the world's poor people. And also you have to keep in mind that this is another aspect of the interest of plants, that the similarity of plants with other organisms, I mean that studying plants can inform us about other organisms, of course, and vice versa. And you all know, for instance, that plants have been instrumental for major discovery in biology. Here, I just give you a few examples about cell biology, discovery of cell structure, the cell theory, cell division has been shown with this specific onion cell, because they were larger, but also, for instance, totipotency, the ability of a cell to regenerate organisms have been studied in plants. And also many aspects of genetic and epigenetic, transposon here or epigenetic here, have been demonstrated starting with plant studies. And also, you know that plants exhibit a huge biodiversity and a very specific ability for adaptation to various environments that is very interesting from a biological or ecological point of view. So to summarize, plants are necessary for life on Earth. They are required for nutrition, health, and well-being of humans, and they provide model for biology and genetic studies. But after 2 decades or several decades of decrease, hunger is again on the rise. So you see a decrease during the last 20 years until 2015, decrease from 13 to 7%. And now for a few years, for 5 years, it increased and reached, I think this year, 10%. Of course, there are not only a biological problem, there are also wars, etc. You are aware, but still there is an increase. And zero hunger is still a sustainable development goal of the United Nations. And also, of course, as you know, it's partly due to the world population that continue to increase. It was a simulation that has been done in 2015, I think, and they planned at this time, so 10 years ago, that we would be in the mean prediction about 8 billion today, and it was true, because we are today, I checked last week, we were about 8 billion, 200 million in this year. So we fit more or less the mid prediction. But if we continue to follow this prediction, it means we can expect to be 10 billion in 2050. Of course, there are not only the number of people is important, but also changes in diet, and especially in developing countries that impact a lot the plant production. And you can see on this slide, in fact, that there is an increase during the last decades in the total kilocalorie per people we are eating. And also there is a very specific during the last year increase in meat consumption in developing countries that of course impact a lot what we have to produce for plant. So this increase in number of people, increase in diet changes will also require that we increase plant production. At least this is what many people expect. Unfortunately, as you know, for 20 years, the global land use for agriculture has peaked and is now even falling. So global arable lands reach a plateau since about 20 years, and it's not possible to extend the area for agriculture. And at the same time, of course, since the population increase, as you know, there is a decrease in the surface available per people. It has been decreased more or less by 2 since the 60s. So according to this fact, we think, people think that an intensification of crop production is still required, especially if the population still increases. Linked to this requirement for increasing the production, we think that there is it explains quite well the increase in the use of inorganic fertilizer. You can see that even during the last 20 years, there is a global increase in the use. Perhaps, I don't know if it will be confirmed or not, perhaps finally a good news. I don't know if it's just random or it's a real trend for the next years. There is a small decrease during the last 2 years. I don't know, but globally, we still use a lot of inorganic fertilizer. And as you know, many of them are non-renewable, and it's difficult to extract them. It requires, or to produce them, it requires a huge amount of energy to produce or extract them. And as you know, their use and overuse of this fertilizer cause pollution. Come back. And moreover, in addition to this pollution of inorganic fertilizer, as you know, for world farm greenhouse gas emission continue to increase. You see the situation during the last 20 years, contributing to the impact of agriculture and climate changes, and all what Philippe Sief, for instance, shown you also last week. And these climate changes increase the global temperature. Of course, you will hear more about that this week, but the observed change in global surface temperature since the last century indicate or suggest that there is an increase of at least 1 degree today compared to a century ago. And according to the different scenario made by different people, but especially IPCC, they predict that depending on the different scenarios, there will be an increase of 1.5 to 4 degrees during the next century. And of course, you can imagine 1.5 is still manageable, but 4 degrees could be much more difficult to cope with. And in the same time, agriculture still consumes about 70% of the total, what they call blue water, available water on the planet. And withdrawal still increase during the last years, although we probably reach a plateau for different reasons. And at the same time, there is an increase in water stress. This is a global demonstration. And here in red, you can see water stress calculated according to the withdrawal compared to available water. And in the mean agriculture area, you increase the number of water stress, and you saw that is really a problem everywhere. not only in Europe and America, but also in North Africa, for instance. You heard Faudi last week talking about that. And the climate change impact the agricultural system worldwide, it's just a few illustrations, but in average, FAO statistic plan that by 2030, there will be a decrease in most of the crop production by 10 to 20%. And of course, it will trigger an increase in the price of all these commodity. And there are several examples, but you saw during last week a few examples, but you have to keep in mind not only heat and drought straits affect the production, but also floods in parallel. And also, as you saw with the presentation of Monica, there is an increase and spreading of the pests due to this climate changes. And still, disease and pests are responsible, okay, depending on the numbers of about 25% of crop loss. But still, what is important, they continue to spread due in part to the type of agriculture, but not only due to the development, of course, of transport and climate changes. So, of course, obviously, because you still have this pest, etc., pesticide use still increase at the global level, plus 50% at the global level, even if it's reach a plateau or can even decrease in some of the countries, for instance, in Europe. And of course, the overuse of plant protection products are a real agronomic problem because it increases the resistance. This is the example of resistance to herbicide, but it's the same for fungicide, etc. If more you use this pesticide, more you increase the resistance, the appearance of a resistance organism. And of course, all that has threatened the biodiversity. And I suppose that Paul will give a few words about biodiversity. And in the same time, at the global level, there is a plateau in most of the crop yield production. Even for wheat, for instance, in Europe, it's also it's reaching a plateau. I think perhaps we will have some comment about that. But this is a real problem. And during the last week, we also saw something I didn't notice in my presentation before, but many people were talking about another additional problem. This is what they call at the beginning plant blindness. It has been now renamed plant awareness disparity, but this is a tendency of humans to not value or not giving the plant the importance they deserve. And for that, they illustrate this a nice picture telling that although plants are everywhere, we mainly see animals, and in fact, I should say probably a human in our environment more than the plants that are so important. So in conclusion of this introduction, the industrialization of agriculture allowed to absorb the demographic increase of the last century. So you will see, and you have seen some seminar about this topic, but I summarize, there is still an increase in the demand for plant products due to the increase in population, in changing diets, but also the requirement by some countries to use biomass to replace fossil carbon. In the same time, as you saw, there are environmental constraints that increase, that we have to take more and more into account. As you know, resources are limited, soil, water, energy, biodiversity, etc. We need to reduce the impact of agriculture on the environment and to maintain the biodiversity for ecosystem service, etc., and for the life. And we need to adapt plant to climate change and the impact on biotic and abiotic stresses, of course. So this is what many people call, I'm not a specialist of that, but we need to produce more and better in the same time. So they call it sustainable intensification. And of course, to meet these challenges of sustainable intensification, we know that there are many leverage effects. And here we are talking mainly about one, but we want to take into account the others. One of the first ways is to change the socioeconomic practice. You will have some talk about this aspect for food and other things, but we are sure we can choose, we can change and improve some industrial practice, some socioeconomic, the organization of food system, and some bioeconomy and the policy. Of course, we can improve farming practice, At INRAE, for instance, we talk a lot about agroecology, precision agriculture, but also how to manage better resources, all the resources I presented. So these are two strong, important ways to meet this challenge. But of course, for our community, and this is one also of the main points, we think that plants and crop improvement in general can participate to tackle this challenge. And there are a strong interaction between changing the farming or industrial practice and crop improvement. And this is a last point also, because we had this discussion, so I led this slide about the different type of agriculture. At this time, 2/3 of the global output is made by agro-industrial agriculture. This is more or less the truth. So it means large scale, highly mechanized, high input agriculture, focusing on maximizing yield and efficiency. This is still 2/3 of the agriculture. And still, it will remain for some years, for many reasons, this type of agriculture. We have still a traditional small farm family. It's very important because it's a small scale and subsistence or local market-oriented agriculture. It feeds many people, but at the economic level, it has a very low impact, because in fact, a large part of this production is not going to the global market, etc. And there are all other types of agriculture. I put in this third category many different things, organic agriculture, for instance, but also urban or regenerative system, etc. That still account for less than 10% of the agriculture. And from my point of view, all this agriculture will be developed in one way or in the other, but all need to be improved in more sustainable way, for different aspects, for a more agroecological aspect, for socio-economic aspect, for many aspects, but all need to be improved from agronomic, social, economic, and environmental point of view. And we think that plant breeding can and should contribute to improve all these different types of agriculture. We can help by plant breeding to develop the sustainability of this different agriculture. So we think that plants are still part of the solution to fill the sustainable development goal. And I summarize here a few of the goals where plants can have a strong impact. I already described no poverty, zero hunger, but also the problem with water, with economic growth. I gave a slide, the responsible consumption, of course, of plants, because you know that laws are very important. Michel, that is here, I think we will be able to talk about this point. Climate action, of course, and the use of land. So this is a summary of the. So, yeah, just to summarize, we think that plant breeding is required to meet the diverse need of all the people that are involved, not only the consumer, of course. The farmers also need us to be sure about their income. The industry need to have the good product, and the society and environment need sustainability at the socio and environmental point of view. So plant breeding is important to secure production and income, but to adapt plant to various environments for food security, for food safety. This is something a little bit different you saw during the last week. And for developing bioeconomy, it will be the purpose of the topic of several seminars at the end of the week, how to develop more bioeconomy. And of course, develop plants to protect the environment by adapting plant to agroecological practice, by enhancing natural plant defense, etc., etc. So, last, taking into account all what I told you, the increase for need for food security and safety, increasing environmental constraints, resource limitation, climate change, etc. The role of plants in agriculture, in the various type of agriculture, the role of plants in biology also, because it's still, as I told you, very interesting. And the human tendency not to give the plant the importance they deserve. We wish, during this workshop, to ask the main question, in this context, in this global context, what are the priorities for research, but not only for research, also for teaching, innovation, communication, outreach activity in plant science. We need to go on all these different direction, not only research, but taking into account everything, as we already discussed a little bit last week. And at the end, how plant scientists can contribute to meet all these challenges. Of course, hopefully, not hopefully, fortunately, we are not the only one to think about that, and more scientists are looking into this issue. There are many initiatives or publications about this topic. I summarize a few of them. And in fact, I took the title from this very first publication. Olivier Hamon will be there in the coming days. He will talk about this idea, but there are some initiatives that think about policy, education, research, etc. And next week, previous week, we had some people from the Plantact, and there will be a meeting Plantact in Spain next week, for instance. But there are many people, and we just want to contribute to this reflection and also in the same time adapt our priority accordingly. And so the workshop objective is to brainstorm about all these urgent challenges, from basic research, we heard a lot during the first week, to agriculture and environmental issue. We wish to provide and disseminate afterward the analysis about the importance of the future of plant science and for the plant scientists. So I suggest, at least in the different discussion and area, to produce at the end some SWOT analysis of the different scientific and transversal topic. This is one way, but there are many other ways to provide some analysis of the reflection we will have in the different area. And at the end, we expect, we hope, to be able to provide recommendation to scientists, students, decision maker, politicians, and the general public, why not? And for that, the workshop were organized during the 2 weeks in 3 different topics. The first one is ended during the last week about frontier and plant science fundamental research. We started last week the Feeding the Planet. That will be also the topic for the next 2 days. And we will end the workshop with the plant as factories. And at the same time, in the afternoon, we discuss the different transversal topic about training and teaching, innovation, outreach, and open science and publication also. Yeah. So the morning session are devoted to seminars, and afternoon session will be devoted to brainstorming. And I'll just give you again the program. So I will let the floor to Paul Ledley. After we will have a break, and we will have Christian Huyghe and Catherine Feuillet that will talk after. And this afternoon, we will have an introduction. I think Gregory is here, but Denis will talk about PCI open publication. And after we will have some discussion about how to feed the world and open science in different groups. And we'll have a restitution at the end of the day. So I think that's all. And thank you very much for your attention.